universe is one big mystery, and we've been finding exoplanets ever since we sent telescopes powerful enough to detect them into space. Proxima is one of the most intriguing exoplanets, and as such, scientists, including those employed by NASA, have spent a significant amount of time studying it. Is there life on this fascinating planet? What have they discovered? Join us as we investigate NASA's investigation of Proxima B, which reveals its secrets. Because of its location outside the solar system, another planet was discovered less than 6 years ago. The planet is an exoplanet known as Proxima Centauri B, or simply Proxima B. Astronomers have discovered a large and growing number of Earth-sized exoplanets orbiting distant stars in recent years. Some stars are in habitable zones, where temperatures may allow liquid water to exist on their surfaces. Proxima Centauri B, on the other hand, piqued scientists' interest because the sun it orbits is the closest star to our Sun, only 4.2 light-years away. Guilherme Anglada Escude and a team of astronomers from the Pale Red Dot campaign discovered Proxima B. Its existence was confirmed further using the High-Accuracy Radial Velocity Planet Searcher, or HARP spectrograph, on the ESO 36-meter telescope using Doppler spectroscopy, or the radial velocity method. This method involves observing the spectrum of stars for signs of a wobble, which occurs when a star moves closer and farther away from Earth. This is caused by the gravitational influence of planets orbiting the star, the extent of which is used to calculate the planet's mass. In the case of Proxima B, astronomers obtained a maximum mass estimate of 1.24 and a maximum mass estimate of 2.06 Earth masses. The presence of Proxima B was confirmed once more in 2020 by the ESO's Very Large Telescope, VLT, and ESPRESSO. It's a shell spectrograph for rocky exoplanets and stable spectroscopic observations. The transit method has been used to discover the majority of exoplanets discovered to date. That method, however, was not applicable to Proxima Centauri, a low-mass and less bright M-type or red dwarf star. Proxima Centauri B is roughly the same size as Earth. It weighs 1.17 Earth masses. In comparison to our Earth's year-long orbit around the Sun, it orbits its star in only 11.2 days. That implies that Proxima Centauri B is much closer to its star than Earth is to the Sun. However, because the star is a red dwarf, which is much smaller and cooler than our Sun, its orbit is within Proxima Centauri's habitable zone. Proxima Centauri B, interestingly, receives roughly the same amount of solar energy from its star as Earth does from our Sun. This implies that water may exist on the surface of Proxima Centauri B. It might be habitable. Of course, we don't yet know all the specifics about exo-world habitability. However, many factors influence the planet's habitability, including temperature, the composition of the planet's atmosphere, the presence or absence of water, and solar radiation. Red dwarfs, such as Proxima Centauri, are known to emit flares, which can make the habitability of red dwarf exoplanets even more complex and interesting, as seen in this video. When astronomers confirmed its existence in 2016, scientists tried to figure out if this exoplanet could support life. Sure, it was in its star's habitable zone, but some studies soon cast doubt on the possibility of alien life. As a result, the question of whether life could exist on Proxima B has always divided scientists. All of these studies, however, indicate that this question will remain unanswered until astronomers characterize Proxima B's atmosphere, ideally by observing it as it passes in front of or transits its host star. However, in a new NASA-funded study, astrophysicists at the University of Chicago determined that this is an unlikely possibility. Emily A. Gilbert led the study that described their findings. Emily is a graduate student in the Department of Astronomy and Astrophysics at the University of Chicago. She was joined by researchers from the University of Maryland Center for Space Science and Technology and NASA's Goddard Space Flight Center's Exoplanet and Stellar Astrophysics Laboratory. However, even if life does exist on Proxima B, there appears to be something that will make it very difficult. It's referred to as space weather. When you hear the word weather, you automatically think of the sun, clouds, rain, wind, and so on. If you're familiar with weather on other planets or moons with atmospheres, you might think of that type of weather as well. However, none of this is related to space weather. It's the kind of weather that forms in stars, including our own sun, and pervades the space around them. Ionizing radiation emitted by flares on the sun or other stars is what causes space weather. any life forms on distant planets could be killed by the radiation. This is especially true for red dwarf stars, which have more frequent flares than our Sun, according to astronomers. Red dwarf stars, of which Proxima Centauri is one, can be extremely volatile. Radio waves were used by astronomers at the University of Sydney in Australia to detect and probe the space weather near Proxima. This, our Sun's nearest neighbour, is known to be orbited by at least 2 planets. One is Proxima Centauri B, which is almost as massive as Earth, and the other is Proxima Centauri C, which is about 7 times more massive. Proxima Centauri B also orbits within the habitable zone of its star, where temperatures may permit liquid water to exist on the planet's surface. If you're nodding your head at these as a sign of life, you're going to be disappointed. The discovery of flares on stars such as Proxima suggests a bleak future for life on the planets in this system. Proxima Centauri B is subject to intense ionizing radiation outbursts from its star. Because Proxima Centauri B is so close to the star, Proxima Centauri, it's important to remember that just because an exoplanet is in the habitable zone doesn't mean it can be inhabited. This is true of Proxima B. Because Proxima Centauri is a small, cool red dwarf star, the habitable zone is very close to the star, much closer in than Mercury is to our Sun. According to research, this makes the planet extremely vulnerable to dangerous ionizing radiation, which could effectively sterilize the planets. Our Sun, however, regularly emits hot clouds of ionized particles during coronal mass ejections. However, because the Sun is much hotter than Proxima Centauri and other red dwarf stars, our habitable zone is far from the Sun's surface, implying that the Earth is a relatively long way from these events, and thus this radiation does not affect us as strongly. Furthermore, the Earth has a very strong planetary magnetic field that protects us from these powerful solar plasma blasts. Scientists may conclude from studying the space weather around Proxima Centauri that all red dwarf stars are not the best places for life. However, other factors, such as the planet's distance from the star, the strength of its magnetic field, if it has one, and so on, could be at work here. Some red dwarfs are probably more active than others, so making a blanket statement about red dwarf situations is difficult. In addition to investigating the possibility of life on Proxima B, scientists have attempted to determine what the Earth would look like as a planet if it orbited Proxima Centauri. They used modelling to predict how the situation would unfold. We're back to the idea of habitable zones. Proxima B's orbit is in the habitable zone, which is the distance from its host star where water could pool on the planet's surface, but that doesn't mean it's livable. It does not consider, for example, whether water exists on the planet or whether an atmosphere could exist in that orbit. Atmospheres are also necessary for life as we know it because they allow for climate regulation, the preservation of water-friendly surfaces, protection from hazardous space weather, and the storage of life's chemical building blocks. The scientists used Earth's atmosphere, magnetic field, and gravity as proxies for Proxima Bs in their computer model. They also calculated how much radiation Proxima Centauri emits on average, using data from NASA's Chandra X-ray Observatory. Their model simulates how the host star's intense radiation and frequent flaring affect the exoplanet's atmosphere using these data. When high-energy extreme ultraviolet radiation ionizes atmospheric gases, knocking off electrons and producing a swathe of electrically charged particles, an active red dwarf star like Proxima Centauri strips away the atmosphere. The newly formed electrons gain enough energy during this process to easily escape the planet's gravity and race out of the atmosphere. Opposite charges attract each other. As more negatively charged electrons leave the atmosphere, they cause a powerful charge separation, which pulls positively charged ions out into space with them. Proxima B experiences bouts of extreme ultraviolet radiation, hundreds of times stronger than the Earth does from the Sun, in Proxima Centauri's habitable zone. That radiation generates enough energy to strip away not only the lightest molecules of hydrogen, but also heavier elements like oxygen and nitrogen over time. According to the model, Proxima enters powerful radiation and drains the Earth-like atmosphere up to 100 times faster than what happens on Earth. The scientists looked at 2 other factors that exacerbate atmospheric loss to better understand how the process can vary. First, they considered the temperature of the thermosphere, or neutral atmosphere. They discovered that as the thermosphere warms due to the increased stellar radiation, atmospheric escape increases. In the comments section below, tell us what you think about life on Proxima B.